every time there's a change in the environment, you have to restart most of the proxies.
Correct.
Literally,
Correct.
the process has to go down and up. And I felt this very much working with NGINX. Suddenly, when I started using Envoy, I didn't understand, wait, where's the restart? You don't need to restart. There's such thing as a dynamic configuration. Not only it's about the static file, it's also about being able to change the configuration without downtime to the process.
Exactly.
ברוכים הבאים לפרק נוסף של בוקר קוד, פודקאסט על תוכנה, תהליכים והאנשים שביניהם. אני, איסן ריפקין, המנחה שלכם, ובפרק זה נדבר על תקשורת בעולם המודרני של מיקרוסרוויסים, בדגש על סרוויס פרוקסי וסרוויס מש. אחד מאבני הבניין של עולם המיקרוסרוויסים הוא פרוקסי בשם Envoy. אם עוד לא שמעתם עליו, הוא מוטמע בחברות ענק כמו מייקרוסופט, אמזון, גוגל, Airbnb ועוד. יש לו מעל 21,000 סטארים בגיט-האב, ומעל ל1,000 תורמים. לטובת פרק זה חיפשתי מומחה בתחום, והגעתי עד למקור, היוצר של Envoy, מאט קליין. כיום הוא עובד בחברת Lyft, הוא בהנהלה של ארגון CNCF, בעברו עבד בטוויטר על מנגנון הפרוקסי שלהם, וב-AWS על EC2. הפרק יעשה בשפה האנגלית לטובת האורח. So, Matt, hi.
Hi, thanks for having me.
Thank you for being with us today. Maybe in your own words, tell us a little bit about you.
Sure. I'm a software engineer. I've been in the technology industry for over 20 years. My career has mostly been in low-level systems, so operating systems and virtualization and networking and those types of things. So for the first 10 plus years of my career, I mostly worked on operating systems and embedded systems. And then about 12, 13 years ago, I switched to working on application distributed systems. So I worked at Amazon. I was relatively early on within EC2. I worked on high performance computing and networking. And then I left there and I worked at Twitter for several years. I worked on their edge networking systems and built, the proxy that was the cursor to Envoy. And then I left Twitter and I have been at Lyft for now coming up actually on 8 years. And, at Lyft, I've done a fair number of things, but I'm most known for starting the Envoy Proxy project.
Wow. So this is a fairly rich history with experience. I do have one question for you. Do you get discount for ordering taxis?
Not too much. There's a small discount, but not too much. Yeah, have to pay like everyone else.
All right. Actually, before we dive into what Envoy is, which is the main thing, I want to ask you a more general question. What is a proxy, a service proxy / reverse proxy? What is it?
Sure. So for those of you that don't know, modern computing systems, they're composed of many different computers. It's not like when you connect to a google.com or a lyft.com or a facebook.com or any other of the large web properties that people know. It's not like you're connecting to one computer. You've got your phone, typically an app that's running on iOS or Android or something that's running in your web browser. And you're talking to a front-end system and you're talking back and forth over APIs. And then as you actually communicate with those systems, that work is being farmed out to potentially thousands of different computers. All of these computers have to talk to each other, and they can talk to each other, using networking protocols that we all know, whether those be HTTP or TCP or UDP or, a variety of different protocols. But there's a lot of other things that have to happen in these systems. There might be security, things like TLS termination. There might be authentication and authorization. There'll be service discovery, finding things to talk to. There'll be load balancing. There'll be all these different things. People have to solve these problems in a variety of different ways. And one of the ways that people can do this is, they can have libraries that will sit in any different language, and they can provide some of these concerns. And another way is by using what we call proxy. This is a piece of software that, just like its name, proxy. It's taking information from one side, it's processing it in certain ways, and it's sending that information off to some other place, and it's getting a response, and it's typically sending it back. And that proxy can encapsulate all of the functionality that I was previously talking about. So again, things like security, authentication, authorization, load balancing, service discovery, fault tolerance, the list goes on and on and on. So in terms of, proxies or web servers, some of the ones that your listeners have almost definitely heard of, or, projects like Apache, projects like NGINX, HA Proxy, these are extremely popular and widely deployed proxies and web servers, that came out either in the 90s or in the early 2000s. And Envoy is a more modern proxy, that was created in the mid 2010s, and it has a variety of different functionality, but it was definitely born during a different time in our computing industry where things were moving to being much more dynamic. So whereas earlier within these distributed systems, you might have fixed machines running in a data center, and then we moved to virtual machines that were, still basically fixed machines. Now, we've moved into a world in which we have container scheduling systems, whether that be something like Kubernetes, or, if you're looking at the managed offerings like Amazon ECS or things like that. And then we're moving even further into functional systems. So things like Lambda, functions as a service. So all of these things they're much more dynamic. They're coming and going. So Envoy was built during a time in which these distributed systems, there's many more moving parts, and that creates some very interesting design challenges. But at a high level, a proxy is a piece of software that we use in these distributed systems that is taking information from one side, it's doing various transformations and offering various abstractions, it's sending it on, it's getting a response, and it's sending it back.
Is it correct to say that the key factor that changed the way you created Envoy is because the environment became much more dynamic?
I think there are a couple of different reasons that led to the creation of Envoy. We were building a system that would provide best-in-class observability. So letting people understand, typically through dashboards and logs, so metrics and logs, what is happening in their system. And in fact, the very first use case for Envoy at Lyft was really providing dashboards that people had not had previously, that let them understand at a very deep level what is going on. So, and it's almost crazy to me, we're in 2022 now, almost 2023, and today some of the observability that I'm about to talk to, people are going to listen to this podcast and they're going to say, I mean, what's he talking about? Like, we just take that for granted. Things like, given the latency of a particular API request, not just giving you the mean latency, but giving you the P90 latency or the P99 latency, like looking at the histogram percentiles. People will listen to this podcast and say in 2022 or 2023, well, that's obvious. I was like, everyone has percentiles. In 2015, no one had percentiles. I mean, it sounds so obvious, but the observability that was coming out of the state-of-the-art systems back then, whether those be NGINX or HA Proxy, or if you look at Amazon's cloud offerings back then in terms of their ELB, what existed in 2015 versus what they have now, it was very rudimentary. And of course, the industry has come a long way in the last 8 years, and frankly, I think Envoy is a big part of that. I think Envoy has pushed the industry forward in a way of showing what is possible and showing what people expect. So, to answer your question, really, the crux of originally why Envoy came about was we wanted best-in-class observability. People are building these microservice architectures. They're seeing failures. They don't understand why these failures are occurring. We'd like to really visualize what's going on in the system. So we want top-notch observability. And then we're dealing with a high rate of change, and we want to deal with that change well. So make it easy to configure. We want to make it operationally low friction. And then we want to start building in self-healing features. So for example, to take a very simplistic example, in the old world, say in the 90s, where all of the machines are fixed, you might have a configuration file that literally lists out all of the machines. It might list out the IP address of every machine, and you list it out, and that's what you're load balancing against. I mean, that's clearly not the world that we live in today. A lot has happened in the last 20 or 30 years. And so now, having a static configuration file where you list out all the IP addresses, again, people will hear that today and they'll think that's crazy. Like, how did we ever do that? Well, I mean, that's the way that it used to work. And it's systems like Envoy that have provided dynamic service discovery and dynamic load balancing.
So I must say, it's not only that it's a static file. Every time there's a change in the environment, you have to restart most of the proxies.
Correct.
Literally,
Correct.
the process has to go down and up. And I felt this very much working with NGINX. Suddenly, when I started using Envoy, I didn't understand, wait, where's the restart? You don't need to restart. There's such thing as a dynamic configuration. Not only it's about the static file, it's also about being able to change the configuration without downtime to the process.
Exactly. And that's where I was going, which is because of this dynamic changing of the environment, whereas when NGINX was originally created, it was probably fine to have these static files because they didn't change very often. Now we don't live in that world. And Envoy was built from the beginning to be an API-driven, eventually consistent system. So we have an API, it's become known as XDS. So we have a variety of APIs that allow Envoy to be a data plane and cooperate with a control plane, and the control plane can drive Envoy to do various things. So the way that people build these systems is they build control planes that run Envoy, and the control plane will provide routes and endpoints and all of the things that Envoy needs to use, and all of these things can be updated dynamically.
So a moment before we dive into control planes, can we kind of on a high level, can you go through the use cases of where should I use Envoy? Because what I discovered, maybe I used it wrong, you tell me, was mind-blowing because it fits in many different areas of the stack. In service mesh stack could be a small sidecar with a very, very small footprint, but at the same time, it could sit at the edge of some Kubernetes cluster and route all the traffic, thousands of requests per second to many different services and different protocols, so you can have gRPC. Can you go briefly through where Envoy fits?
So coming back to what you asked me originally around what is a proxy, we went through what a proxy is. The follow-up to that is that even apart from Envoy, proxies are pervasive within today's systems. People use them all over the place. Now, Envoy, because it is so feature-rich, it supports, MongoDB and Redis and like Kafka, and it supports TCP and Quick and HTTP3, and I mean, so many features. We have Envoy Mobile that runs on iOS and Android. It's like Envoy can run in so many different environments, from the mobile phone to Edge API gateway to service proxy. The service proxy could be like a sidecar type thing. People use Envoy in all of these situations. It's used all over the place. So I don't know that there is a right or wrong way. I think people will find uses for proxies in almost any system in which we have networking happening.
Specifically Envoy as a standalone mechanism, what does it provide? So you said observability. What else? You mentioned also many protocols. Can it proxy all those protocols?
Correct. Yeah. So Envoy at its core is a layer 4 proxy. So by layer 4, there's the networking levels. The ones that people most typically know of are layer 4. Those are things like TCP and UDP, or what we call layer 7. Those are application protocols, so things like HTTP or gRPC. So Envoy at its core is a layer 4 proxy, meaning it can it can take in traffic. It can have routing rules based on where that traffic is coming and where you want to send it to. It has management of backends, which is really its core feature that's protocol agnostic. So by backends, I mean proxies take in traffic and they send it somewhere. You have to know where that somewhere is. So that, is what we call service discovery. It's finding, these backend endpoints. That could happen using XDS. It could happen using DNS. Then we have load balancing, right? So it's like we have to decide which of these backends we're going to send that request to. We have health checking. So Envoy supports both active and passive health checking. Active health checking would be every so often I'm going to send a ping request or something like that to the backend to see if it responds. And if it doesn't respond, I'll mark it unhealthy. Passive health checking would be monitoring traffic in real time. And if the backend is failing, I might preemptively drop that backend. So load balancing, service discovery, these are actually a big brunt of what Envoy does, and it's very complicated. Like the load balancing algorithms are complicated. Envoy supports very sophisticated load balancing, so it supports priorities, it supports failover between zones, it supports traffic affinity. So in modern traffic engineering, there's a lot here. So a big brunt of what Envoy does is in these types of features. So cluster discovery, load balancing, health checking. Then in terms of routing, as Envoy knows about the protocols that people are routing, it can do very sophisticated routing. So for example, if we're talking about HTTP, it can route based on headers, or it can route, whatever, based on content type, or based on all types of different things. And then it can filter traffic, and it can do transformations. So we can do transcoding. So, it can basically take like HTTP traffic, and it can transcode it into gRPC. It can do, security-based protocols, whether that be JOT authentication or OAuth. It can do fault injection. It can do observability. It can do tracing. So again, there's like a huge amount of functionality here. And depending on where you're using Envoy, you're not going to use all the functionality. And again, as I said before, to its detriment, sometimes Envoy is a very sophisticated piece of software. And the reality is that many people will consume Envoy in a layered approach, meaning they will consume products that use Envoy. They will not consume Envoy directly because it's such a sophisticated piece of software. It's a building block that might use them.
I would like to deep dive filters. What is the idea of filters? What can you do with them? The follow-up question, when are they starting to impact performance?
Sure. Idea of a filter within Envoy is Envoy at its core is a layer 4 proxy, meaning we're operating on bytes. And in its simplest form, the bytes come in from a client, and they're going to go out to a backend, like I was saying before, based on service discovery and load balancing rules and health checking and so on. But before the bytes go out to the back end, I might want to transform those bytes, or I might want to inspect those bytes. That's where filters come in, and filters operate in a particular order. This is not a novel concept. I mean, many networking systems have a similar type of thing, but in Envoy, you can configure what we call a filter chain, and the filter chain again could be a simple thing. It could be, it could be a filter that literally counts the bytes or something like that, or it could be a very complicated filter. So, for example, let's say that we have a protocol parser that spits out observability on what's going by. So we have a MongoDB filter, which actually parses the MongoDB traffic and spits out observability on the traffic. It doesn't do anything more with it, but that observability can be very useful. And then we have a layer 4 filter, which we call the HTTP connection manager, which is incredibly complicated. And that takes the bytes and then it parses it into HTTP 1 or HTTP 2 or HTTP 3. And then there's a parallel layer 7 filter chain, which can then operate on HTTP concepts like body bytes or headers or trailers or those types of things where you can do similar transforms. And at this point, we have many, many, many filters that operate on different protocols and provide different functionality that range from fault injection, rate limiting, security, observability, the list goes on and on and on. But the idea behind filters is that the functionality is encapsulated and in fact can be compiled out. So if you don't care about certain types of things, you can actually completely get rid of it. And that is the filter or the extension based architecture. And I should add that Envoy, one of its design principles has been to be very extensible. From a project perspective, we like to say that we never say no. We never say no to someone that wants to contribute something, but we might instead say, this doesn't feel like a good fit for something that we would maintain for everyone, but let's build an extension point so that people can plug in their own functionality.
Yeah, and especially the fact that it has configurable APIs, XDS. This means that something needs to manage it. A very interesting post that you wrote on the state of Envoy Proxy control planes. What is a control plane?
Yeah, so like we were saying before, Envoy is, for better or worse, a very sophisticated piece of software that has a ton of different functionality, and it can be configured in real time using a variety of different APIs. So those APIs can provide listener configuration and backend cluster configuration, endpoint configuration, route configuration, and so on. So something has to drive that configuration, and that is a control plane. And control planes, as it turns out, are non-trivial to write. I mean, they themselves have to interoperate with the sources of truth, which is implementation specific. So whether that be Kubernetes or GitHub or however people are doing the rest of their system, control planes have to know that information, and they have to serve it to the envoys in a scalable and fault-tolerant manner. And it turns out that this is hard. I mean, again, there's no free lunch in these systems. Like, these things are just hard to build. A whole ecosystem has sprung up around Envoy in terms of control planes. Obviously there's Istio, there's Kuma, there's a variety of different API gateways, whether that be Ambassador or Contour. Now we actually have the Envoy Gateway project, which is building a higher layer, easier to consume API gateway for Kubernetes on top of Envoy and open source. There's quite a few vendors that do it. Like Google has their own system in terms of traffic director, and all of their backend systems use Envoy. So people have built their own control planes based on a library which we call Go control plane. So, I mean, it is a large space with a lot of different players. And like I was saying before, I'm a big believer that we will continue to move to more integrated platforms. So functions as a service or platforms as a service, where things like Kubernetes and Envoy, they're there, people don't interact with them.
You mentioned the library, the Go control plane.
So XDS itself is a non-trivial protocol, and we have a library in Go called Go control plane, which is a helper library that people have used to build their own control planes. So lots of large companies use Envoy, and a lot of them have custom control planes because they integrate with their own data sources, right? It's like, as I was saying before, when you reach the control plane layer, you're feeding information into Envoy that can come from a lot of different places. It really depends on how your organization configures things like routes and services and all of those things. Like, Envoy can't know that. So Envoy has an abstraction that allows it to be driven by an API, and then the API can be controlled from the control plane and get its data from different sources. So Go control plane is a library that helps people to build their own control planes.
What would be the hello world of a control plane?
I mean, probably the easiest thing would be to bring it up and provide something very basic to Envoy, right? It's like, listen on port 80 or something like that, and, return a 200. I mean, that would be the basic thing. And then from there, obviously it can expand in complexity by a huge amount, depending on what people are attempting to do with it.
What's the best path for me, the path of least resistance to start and learning and understanding what can I do with Envoy?
I always find it funny with Envoy because I will hear within the same week 2 statements. Statement 1, Envoy, has the worst documentation I've ever seen. It is incomprehensible. Like, I don't understand how anyone ever uses this project. It is so awful. And then I will hear, Envoy has the best documentation of any open source project I've ever seen. It is amazing. Like, wow, these people are awesome. The reason that I'm saying that is that it is impossible to satisfy everyone, right? It's like, it is, and that's why we have layered abstractions. So If you are looking to use Envoy directly, we have within our documentation, we have 20 or 30 now different sandboxes. So these are Docker Compose things that bring up Envoy with different scenarios and different configurations. I think that's a great way of getting started because it lets you bring up different scenarios using Docker Compose, look at the config, like try to understand it, play with it, and then get into it from there. So that's probably how I would start.
Okay, so thanks. And I wonder if you have a recommended book.
Recommended book. Wow. Nothing in particular. I go through spurts of reading, and I did read a book that I really enjoyed recently. It was about the Virgin Galactic space program. I think it's called Test Gods. And I mean, that's just one that I read recently that I really enjoyed. There's lots of books about space, but this was one that I particularly enjoyed just from some of the engineering perspectives and just kind of what went into trying to make a space plane work as opposed to a lot of the rocket stuff that we typically hear about.
Great. How can people consume more of your content? Where can they find you?
I would have typically said Twitter, but I don't know. I'm not sure. I'm not sure what's going on Twitter, but you can reach me over email, still on Twitter. I do have office hours, so always happy to chat, which you can find on my website.
Yeah, and I also make sure to include them in the note shows.
Yeah, thank you.
Thank you very much. It was a great pleasure having you here.
Happy to. Yeah, thanks for having me.
עד כאן, פרק נוסף של בוקר קוד. עקבו אחרי עמוד הפייסבוק של הפודקאסט בוקר קוד על מנת להתעדכן בתכנים מעניינים ובחדשים ביותר. כמו כן ניתן להאזין לפרקים בכל הפלטפורמות האהובות עליכם, אם זה ספוטיפיי, אייטיונס, גוגל פודקאסט ועוד. תודה רבה.